this A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on extending your knowledge of Boolean logic. Boolean logic was introduced at GCSE, where we covered the NOT, AND, OR, and XOR logic gates. Each one of these has its own logic gate symbol, truth table, and Boolean expression symbol. For a quick recap of these, the NOT gate has one input and one output. The output is always the opposite of the input. The AND gate has two inputs and one output. The output is 1 if both inputs are 1 and 0 in all other cases. The OR gate accepts two inputs as well and will output a 1 if either of the inputs is a 1. The only time it will output 0 is if both outputs are 0. The XOR, or exclusive OR gate, also accepts two inputs. The output will be 1 if the two inputs are different, that is, a 0 and a 1 or a 1 and a 0, and it will be 0 if they're both the same, either both zeros or both ones. Let's take a look at the first new logic gate for A-level, the NOR gate. The NOR gate effectively inverts a normal OR gate. The NOR gate, like the OR gate, accepts two inputs. In this case, the output is 1 if both inputs are 0 and 0 in all other cases. The logic gate symbol for the NOR gate looks like the OR gate with a little circle on the top. The Boolean expression for the NOR gate has the normal A or B symbol with an overline over the top to indicate NOT. The other new logic gate at A-level is the NAND gate. The NAND gate inverts a normal AND gate. It also accepts two inputs. The output of a NAND gate is 1 if either input is 0 and 0 only when both inputs are 1. The logic gate symbol for NAND is the same as an AND symbol, except there's a circle on the top of the D shape. The Boolean expression for a NAND is the usual expression A dot B for an AND, with an overline representing NOT to signify NOT AND, or NAND. Both the NAND and NOR gates are considered to be universal gates. This is because you can construct any other common gate types using only NAND gates or NOR gates. This has massive production advantages, meaning that they can produce a lot more of these, making them much cheaper. Logic circuits are made up of multiple inputs and multiple gates. The output of each gate will be represented in a truth table. At A-level, the new logic gates that we've just learned about, NOR and NAND, may also appear in the logic circuits you're asked to interpret. A couple of reminders now for creating truth tables for logic circuits. First of all, if you have three inputs, don't just randomly select zeros and ones for each of the columns. Count up from 0 up to 7 in binary, so 0, 0, 0, 0, 0, 1, 0, 1, 0, counting up by 1 each time. This will stop you from accidentally repeating a combination or missing out a combination when you construct your truth table. First, we need to create a new column to store the result of the A and B inputs going through the NOR gate. This means that they'll have an output of 0 unless both inputs are 0. So we get 1, 1, and all the rest of them are zeros. The result of this then goes through a NAND gate with input C. So now we're looking at these two inputs, and the output will be 1 unless both inputs are 1. So we can see our final output in this case would be 1, 0, and then all ones all the way down to the bottom. As well as being able to construct truth tables for logic circuits, you should be able to construct a logic circuit based on the equivalent logic statement, or a logic statement based on an equivalent logic circuit. That brings us to the end of this video extending your knowledge of Boolean logic. Join me in the next video when I'll be looking at the half adder and the full adder. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.